Hello. How's it going? I'm an architect on the HipChat team, so I thought I'd talk about some HipChat stuff. We're going to go over what history is in HipChat. We're going to talk about how HipChat is a big monolith. Talk about why we're going to do some microservice stuff. How we can speed up a local dev loop when dealing with microservices. And we're going to go to the cloud. So let's talk about what history is and why history is so important to HipChat. Without history, HipChat's kind of like talking to a fish. So what I mean by that is every time you would bring up HipChat, it would look something like this. You'd have to start your conversations all over again every time. For example, without history, HipChat would be like talking to a fish. Every time you opened it up, it would look like this, and you would have to start your conversations all over again. Nobody wants that. So, the monolith. Let's talk about what a monolith is. Most people that think about a monolith envision something in their minds sort of like spaghetti. But monoliths don't have to be inherently evil. They don't have to be all spaghettied together. You can have a reasonable monolith. Something that looks like this. We have HipChat core. It's got well-defined functional areas. They just happen to live in the same package. So I can take this package, and I can deploy multiple of them, and I can send any request for anything to any of these monoliths, right? If I need history, send it to the monolith. I need emoticons, @mentions, whatever it is, I can send any request to any of these, and I can sort of scale them by deploying lots of them. So that begs the question, why microservices? Now, if you ask 10 people, why should I use microservices, you'll get 10 answers, ranging from don't use them, they make everything complicated, to you should use them for everything because they solve all your problems. What was the question? The answer is microservices. So I've come up with what I feel is a pretty simple way to illustrate why somebody would go with microservices. But I'm going to need your help to do it. So how many people here, show of hands, can count to 4? All right, it's almost everybody. Great. Don't worry about it. I'm going to be doing the counting. So here's what we're going to do. Everybody, hold out your hands like this in front of you. What we're going to do is I'm going to count to 4, and we're all going to clap like seals. You cannot bend your arms. That's a rule. All right? Here we go. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's pretty awesome. Let's try that again. This time, hands out in front of you, palms together, and we're going to clap like this. Ready? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That was awesome. I'd say give yourselves a round of applause, but, I mean, you just did. So, what did we learn? Basically, we learned isolation equals speed. When we had to move our entire arms to clap, we couldn't clap that fast. When we isolated the movement just to our wrists, we can go a lot faster. We're isolating the change, right? And so we can go a ton faster. The same thing happens when you're talking about deployment, when you're talking about code changes. If I have to deploy the entire monolith just because I want to change history, that's going to take a long time. There's tests. I have to run all the tests for everything. I have to deploy it. I have to make sure everything's working. I have to roll it back if it's broken. And I have to deal with everything all at once. So we need isolation to get faster. So how do we obtain isolation? Docker. How many people use Docker? Yeah? OK, pretty good. So Docker gives us all the isolation we need. It allows us to write in any language we want to. And it allows us to worry about one thing at a time. And what we're worried about for HipChat's history is fulfilling the contract of history, right? I don't care about all the other things in HipChat when I'm just thinking about history. When I want to write a microservice for history, I just care about the contract. So this is what I mean. If we look at, this is the current HipChat API, right? So this is view room history. But what you'll notice is the endpoint has room and then room ID or name / history. So it's actually part of a really big API that's called the Rooms API. And you can kind of get a sense that it's a monolith just by looking at this API. If you look at the sidebar up here, you can see that there's a lot of other stuff it does other than history. You can get the rooms, create the rooms, update rooms. You can do avatars. This is all the same API. If we take a look at the payload for this API, this stuff here, not a lot of history in there. I see @ mentions. I see some link names. I see user IDs. I see a Twitter user. Not sure what that is. There's a whole bunch of stuff in here that is not related to history. So when we went about rewriting history and putting it into a microservice and into a container, we came to this page, and we went, what exactly do we need to do? What exactly is the contract for history, right? And so we basically boiled it down, had our contract. We figured out that history basically just needs to return messages in time slices. So we got our contract figured out. But we also realized we needed to store history somewhere. And when we remove this thing as a microservice out of our monolith, we no longer get the storage that comes with it. So we're actually going to have two services now. We're going to have our history microservice and its storage. So let's go back to our clapping example. I know everybody loved the clapping example, right? Right. So that's one service. That's a single service, which is pretty cool. Not that interesting. What happens if I have some other services? Maybe I have a snapping service, a knee slap service. And those things are great too, but not very interesting. I can tell by your faces that's not very interesting. What makes having multiple services interesting is that they need to work together. They need to be deployed together. They need to run together, but they also have a certain order for them, right? And so in container land, we call this orchestration. And to illustrate with our, now we have multiple services, it looks something like this, right? That's way more interesting than the services just working on their own. So how are we going to orchestrate this stuff? Well, first place to start is our local dev loop. We're going to need this on our local machines. We need all of our services to come up. And we're going to use something called Docker Compose. So in HipChat, historically, pun intended, we would use a dev VM, which is a vagrant image, which includes the entire monolith. It's everything inside of HipChat that you need to run HipChat. But it's highly error-prone. We have to maintain the thing. Anytime somebody makes a change to any part of HipChat, we have to update this dev VM and tell everybody to go download a new vagrant image and all this stuff. And it's really hard. So in microservices, we can use Docker Compose, and it just replaces all of that. And it allows us to run a couple of Dockers at the same time and orchestrate them, like we just talked about. And it's pretty simple to get a service and its data store up very quickly. So this is the entirety of our Docker Compose file for history. You can see we have a thing called historian. It runs on 8080, and it's using Cassandra as its database. And the Cassandra stuff is just basic Cassandra stuff. With this in place, the rest is just typing. I have that file. Now I can do this command, and that'll bring up Cassandra. It'll bring up my history service. The history service will wait for Cassandra to be ready, and then give me a little message, hey, historian's ready to roll on port 8080. Any developer can check out the project and run this command immediately. There's nothing else to install, because it's all containerized, right? We're writing the historian project in Golang, but no developer needs Golang installed on their machine. They can pull the project and say Docker compose up, and it runs. And once it's up and running, we now have our new historian API. And this is just based off of Swagger. So if you haven't heard of Swagger, go check it out. Great way to document stuff. So we have our service, we have our data store, we have our API to the cloud. Right? I feel like I'm forgetting something, though. Oh, yeah, we need test to pass. CI. So this is a screenshot of Bamboo. Hopefully this screenshot is going to change to Bitbucket pipeline sometime soon. And the whole reason for showing this slide is that with Docker and Docker Compose, and we actually put our tests in a third container, so now we have multiple containers running, but with that system, we can treat Bamboo just like another developer. Bamboo just does the same exact commands we do on our local machines. The Docker Compose up, Docker Compose tests up. So now we know that our build is running the exact same stuff we're going to run locally. We also know that the thing that we're testing is the thing that's going to be deployed to production, and then CI just takes care of that for us. So when we talk about deploying, where are we going to deploy to? Well, we chose to use this platform called Mesos. Anybody hear of Mesos? A couple people? Good. So Mesos is container orchestration for the cloud, essentially. Basically, it takes a bunch of machines, in our case, EC2 instances, and makes them look like one big, giant computer. So when I have a service, I just say, this service needs this much CPU and RAM, and Mesos will figure out where to put that. And I don't care. No longer in the job of managing machines. Mesos is doing it for me. I don't care where the Docker runs. Figure it out, please. So it works on this two-level scheduler. So at the bottom, you can see we have our EC2 instances. And the Mesos platform is managing those for us. So they can come up and down. When they come up, they auto-join the cluster. They tell themselves about Mesos. Mesos knows that it has more resources to put microservices on top of. And I never, ever think about that. It's super awesome. On top of that, on top of the Mesos platform, we then have these things called frameworks. So there's one called Marathon built into the Mesos system that schedules Dockers. That's all it does. You give it a Docker and it goes, great, I'll find a place to run it for you. But there are other frameworks that have domain-specific knowledge, like the Cassandra framework. So there's a framework where you can say, I need 15 Cassandra nodes, and this thing will just go out and schedule it for you. It makes opsing this stuff super simple. So who's using this? There's a lot of companies using this, actually. It can scale well. It has a ton of features. A lot of people are liking it. Let's take a few examples. Twitter. Twitter's been using Mesos since 2010, and they've scaled it to tens of thousands of nodes with, I think, 3 or 5 masters, something like a very small number of masters. Apple Siri. Hello, Siri. Anytime you do that, Apple Siri is running on top of Mesos. Nobody's really sure what the number is, but everybody's pretty sure they're the largest Mesos install currently. And our friends over at Netflix. Netflix is using Mesos, but they also wrote their own framework on top of Mesos to schedule their Java jobs. It's called Fenzo. It's open source. You can go check it out. Now, you might be sitting there saying, great, that's Twitter, that's Apple, that's Netflix. I'm a small company. Maybe you're an add-on developer. Maybe you're a company of like 5 people. I don't know. Apple, Twitter, and Netflix, yeah, 2 people, great. Apple, Twitter, and Netflix surely have more time, money, and resources than probably some of you. But somebody can save you. It's a company called Mesosphere. And what they've done is they've created this system called DCOS. It stands for Data Center Operating System. And it gives you all the automation and tooling just like the big companies have written themselves, but sort of in one box. And this is not just for small companies. So Verizon Wireless announced that they're running Mesosphere DCOS in all of their data centers. The Microsoft Azure Cloud is running on top of Mesosphere DCOS. So there are massive companies using the same stuff. Good news for you, it's free, and you can just go do it. Let's see how we go do it. So if you go to mesosphere.io, you'll get this page. And you just click on Get Started. I'm starting from scratch. I'm going to say I need the Marathon Docker scheduler, and I want to run it on AWS. I'm going to do a template install, and I'm going to hunt on this page for the template. Ah, there it is. Click that. I'm going to launch on US East, it looks like. The template's already selected. I'm going to click Next. I'm going to give it a name of Atlas Camp and click Next. Oh, need a key. We'll go ahead and click Next. Just leave that. For review, I'll acknowledge that my template might cause some AWS things to happen. Create it. And there we go. And through the magic of video, this will finish rather quickly. It's not that quick. So if we go to Outputs, it's going to give us a DNS entry of where our Mesos master is. So I can copy that and paste it into a new tab. And we'll get to DCOS screen. So we've just launched an entire cluster in AWS. I'm going to sign into it. You see there's nothing really running, but we do have 6 nodes, 6 AWS nodes connected. We look at the services. We can see that our Marathon thing has been launched. If we go to the Universe tab, we can start installing our data store that our history service needs. So we're going to install Cassandra. I'm going to do the advanced installation, which allows me to change some things, but I'm not actually going to change anything. I'm just going to install it. Once we click Install, that really was that fast. I didn't actually edit the time there. So if we go back over to the services and click on our Marathon tab and open it up, we can see that Cassandra is deploying. I'm going to open this in a new window. All right, Cassandra's deploying. There it is. It's running now. So another thing we need is going to be a front-end load balancer, because we want to have multiple history services, and we want them load balanced. So we're going to go back to the Universe and find this thing called Marathon Load Balancer. That's a thing that is aware of all of our services and can just front them for us with almost 0 configuration. Again, we're just going to review and install this thing. And again, super fast. We'll jump back over to our Marathon screen, and we can see that Marathon Load Balancer is deploying. And it goes green. So now we're ready to create our history service. Just click Create Application. We'll go into JSON mode, and I'm going to copy and paste a descriptor I already had made. It's just telling it where the Docker is, how many instances I need, how much CPU, how much RAM, what port it's on, those sorts of things. I hit Create. And we can see our history service. 2 of them are now deploying. And they're deployed. So now I can go and check out my history service. And there it is. I can do a health check on it. Health check on it. Here we go. And I can go to that Swagger doc I mentioned before. And what's interesting here is because we have a REST API, that's what our service is, one big REST API, this Swagger actually gives us a UI for it, right? So we can fill in these form fields, we can test out endpoints, it'll actually curl or post or whatever it is and get the response back. So it actually gives us a way to test out our service without having to manually curl stuff on a command line or whatever. So if we go back to our Mesos dashboard, we can see it's now telling us how much memory, CPU, we have 7 tasks running. And that's how easy it is to get started with this stuff. We just did the entire cluster setup, and I didn't edit anything other than the time it takes to spin up AWS resources. And that's all free. You can go do it today. So what we just saw, extracting the microservices, using the API as the boundary. We talked about the contract. Using Docker Compose for local development. Treating CI as just another developer, which is awesome. Using Mesosphere to build that cluster, and using the tools to manage and deploy things. What we didn't see, a bunch of code. When we use Docker Compose, Docker, and Mesos, we stopped thinking about deployment. We stopped thinking about how do we scale things. We don't have Puppet. We don't have Chef. You didn't see any configuration management there. All we're doing is worrying about our domain-specific problem. The history domain-specific API is 536 lines of Golang code. That's all we need to build an entire history service for all of HipChat. So, how many people think they're going to go use Docker? Maybe some. How many people think they're going to go test out Mesos? Maybe some. All right. For those of you that didn't raise your hand, and for the rest of you as well, I wanted to make sure everybody gets at least one thing out of this talk. Here it is. Your life is an occasion. Rise to it. Thanks, guys.